Okay, this is still 9-2 notes. I'm getting ready to start number 11, but I wanted to reiterate to you or remind you why we have the rule even, even, odd for when we use an absolute value sign. Remember that we don't know what this x stands for. That original x could have been a positive number or a negative number. Let's say x stood for -1. When I raise it to the fourth power, what do I have? I have +1. That's a positive answer in there underneath the radical sign. So then when I take the fourth root of 1, I get 1. But there's also the rule that you can divide your powers. 4 divided by 4 gives me 1. My answer is x. But I said just a minute ago that x was -1. If I say my answer is x, I'm saying the answer to that radical problem is -1, where in reality it can't be, because I took this -1x, raised it to the fourth power, and got a +1. Then I took the fourth root of a +1, which was a +1, not a -1, which is what x stands for. And that's why we need the absolute value sign around that, to acknowledge that if I was raising it to an even power and got a positive number and then took an even root of that, I have a positive answer, not a negative one. And my original x, I don't know whether it was positive or negative. If it was positive, I'm good. I didn't really even need an absolute value sign. But if it was negative to begin with, I have to acknowledge that the answer that came out was positive. So we use the absolute value sign to account for either the original negative or positive x. Okay, on to number 11. I have b to the fourth power raised to the 1/2 power. 1/2 power, remember, is a square root, so that's the square root of b to the fourth power. Remember, that's an index of 2. We don't write it there, but that's what it is. And so to figure out the answer, I take this power and divide by the index. 4 divided by 2 is 2, and I get b squared. Don't need an absolute value because I have even, even, even. I only need the absolute value sign when I have even, even, odd. Okay, on number 12, there was a typo there. That should have been -64 x to the fifth raised to the 1/6. So that gives me the sixth root of -64 x to the fifth power. Can I take a sixth root, an even root, of a negative answer? That means, are there 6 identical numbers that I can multiply together and get -64? So had that been the sixth root of 64, I could have said that was 2, because 2 raised to the 6th power is 64. But because it's -64, I can't do that. There are not 6 identical positive numbers that would multiply to 64, and there are not 6 identical negative numbers that would multiply to -64. So therefore I can't do it. So I also cannot take the sixth root of x to the fifth because this power, 5, is smaller than my index, so there is no answer to that. Okay, the reason that there's no answer, because I could leave that, the sixth root of x to the fifth, there's no solution to an even root of a negative number. Okay, on number 13, I have the quantity y minus 9 squared raised to the 1/2 power, which means I have the square root of y minus 9 squared. The square root of y minus 9 squared. I divide the power by the index. 2 divided by my understood 2 that's here gives me 1, so that gives me y minus 9. Now, that was even, even, and the power on this is really 1, so that's odd. Even, even, odd means I need absolute value signs around the y minus 9 because I don't know whether that y was originally positive or negative, or that value, I should say, after I subtract 9 from y, whether that value was originally positive or negative. So I have to have the absolute value signs there. Okay, I'm going to quickly describe these definitions, which I understand are a little bit hard to get when you're just reading the definition, but you'll see how they work as we move on to the next problems. First definition says, if x is greater than 0, and I'm raising x to the 1/n power, what you get is a positive number such that if I then raised it to the nth power, which is the denominator, of course, 1/n times n gives you n/n, that's 1, So that's like x to the first power, which is x. If x is equal to 0 and I raise it to the 1 over n power, well, 0 raised to any power is 0 because it just means you're multiplying 0 that many times. If x is less than 0, that means x is a negative number and n is an odd number. For instance, if I'm raising negative 27 to the 1/3 power, that means I'm taking the cubic root of negative 27, and what I get is a negative number because I can take an odd root of a negative number, because that would be asking me to multiply that negative number an odd number of times. I still get a negative number. If x is negative, meaning less than 0, and n is even, for instance, if I have x is negative 8 and I want to raise it to the 1/3 power, excuse me, though I said n is even, to the 1/2 power, I can't take a square root or any even root of a negative number, so the answer you get is not a real number. And we'll see that as we go through the next problems, how that all works. Negative exponents, the rule is move them where they aren't. Meaning if you have a negative exponent in the denominator, we want to move the variable to the numerator to make the exponent positive. If we have a variable that is negative in the numerator, move it to the denominator to make it positive. And again, also we will see how that works when we get to the problems. Okay, the next problem say evaluate and or simplify. So I have to look at each problem and determine what I'm supposed to do with that. I have 32 to the 2/5 power. Now that can be done in your calculator. It would be 32, the caret button, which is the up arrow, 2 divided by 5, math enter enter, and it gives you your answer. Or just enter and you can check and see whether it's going to be a whole number or a fraction. So that can be done in your calculator. If we're doing it by hand, this is the 5th root of 32 squared. That's also the 5th root of 32 squared. It's easier to do the second one because I can take the 5th root of 32 easier than I can square 32. Although if you're using your calculator, it's probably about the same difficulty level. So the 5th root of 32 is 2. So that's 2 squared, which is 4. The 5th root of 32 squared is 4. 81 to the 3 over 4 is the 4th root of 81 cubed. The 4th root of 81 cubed. The 4th root of 81 is 3 because 3 raised to the 4th power is 81. The 4th root of 81 is 3. 3 cubed is 27. So again, I did the 4th root first rather than raise 81 to the 3rd power. 16 to the 3 over 2 is the square root of 16 cubed. So I'm going to put it like that. Square root of 16 is easy for us to take. It's 4, and 4 cubed is 64. Again, each of these can be done in your calculator, and I'll show you that when I get through this section of notes. Okay, 17, I have the cubic root of 125 to the 4th power. I'm going to do the cubic root of 125 and then raise it to the 4th power. You don't have to rewrite it like that, but you can. The cubic root of 125 is 5. 5 to the 4th power is 625.